Hello, everyone. Hi, everyone. Welcome to our webinar today on behalf of Toronto Agile Community. I am Ardita Karai. Another person that is helping me from our group is Peter Jacques, and we will host the webinar with Adam Yuret today. Adam is also online. Quickly to talk about what the plan is for today. So we will introduce Adam, we'll have the presentation. You will have the chance to have questions during the presentation. Any question that you have, please use the question box that you have available. And then at the end, we'll have some follow-up questions. I really want you to stay until the end today. There are some exciting news we want to share with you, but you have to wait until the end. So some housekeeping rules before we start. The attendees will be on mute because of any noises that might be around you, to keep everyone to allow everyone to listen clear the voice and the presentation. Questions, as I mentioned, go on the question box. In case of any technical issue, do try another browser or logging on and off. Sometimes it happens. The audio, you can also use the telephone if you have issues with audio. So you can probably follow us with video and with telephone. A little bit about Adam. So you probably have read what Adam has been doing for a while on our communications with you for this webinar. Adam is a good friend. He lives in Seattle with his lovely wife, Christina, and 2 little boys. He likes to sail and to cook. Sometimes he cooks what he catches. And I am very excited to bring Adam in our community in Toronto, although he's from far away. There are some lean concepts and messages that I've been very excited to hear from Adam before, and I want to share those with you today. Before we start the presentation, I wanted to give a shout out to all our sponsors that have been helping us before and continue to help us. And without their help, we cannot achieve what we do for you. So without further ado, Adam, hi, you exist. I will share my screen and I will give you the power to control the presentation.
Share my screen.
There you are.
Stuff. All right. Hello, Canada Internet. I have told I get the whole of the Canadian Internet today. Thank you for having me, and I appreciate the very generous introduction, Artie. Some of you may have heard of me. I'm kind of a big deal. I just found out people were looking at my LinkedIn profile. Kind of a important milestone going on there. So I'll try not to use up too much time because I'm trying to present a lot in a short period of time. So generally speaking, I'm going to give a sort of brief introduction to some things that deserve a lot of time and try to give you access to dive in on your own at your leisure, either during or after this webinar. So let's get to the chase. What we're here to talk about is data-driven portfolio management. There's a lot of math that is off-putting to people. I like to tell everybody that I've got my PhD in advanced math, specializing in probabilistic forecasting using data. But I only tell them that because I lie. In truth, I wasn't allowed to learn math. I was a high school dropout, and the system dictated that no matter how well I showed aptitude in a given subject, if I did not also show compliance, I was not permitted to pass to the next stage. So consequently, having never passed basic math, I wasn't allowed to take advanced math. So the main message I want to send is, while the things may seem off-puttingly mathematical, even if you have a PhD in stochastic forecasting and understand probability really well, don't let that put you off. You can do this too. So what are we going to talk about today? We've introduced me, and honestly, a lot of times when we talk about the techniques and how they work, people say, well, that was interesting, but I didn't understand why I was learning it. So we're going to jump straight into a brief introduction to the team level single level forecasting, or single feature forecasting tool. All of these tools, just so you know, not a pitch for you to buy anything. These tools are made by Troy. Troy McGinnis is the creator of all of these tools, and he, in his generosity, has made them all available on focusedobjective.com. The link bit.ly/simresources has all of the things we will show, all the things I will show here on it. It's a GitHub link, and you can dive into it again whenever you like. Troy made all of these things, and they're all Creative Commons. They're all free. The main thing that I ask on Troy's behalf is, if you go and dive into them and follow the simple instructions, if you find a place where you got stuck, or you went into it and said, I don't understand this, don't assume that you don't understand it because of you. Reach out to Troy. He's very accessible, either on Twitter at @TMcGinnis, T_McGinnis, or at his email address, which is troy.mcginnis@focusedobjective.com. And you're welcome to email me as well. I'll do the best I can to answer your questions. The real key here is we want it to be really easy to use, so people use it, because we've seen good outcomes from using it. So, the tool. Oh. Don't be off-put by the math. If you can do this, you can Monte Carlo. Psychological safety is essential to good data. If you don't have an environment where people can ask questions, or where data is not used abusively, then the information you get will be misleading and inaccurate. So the single feature forecaster, also on bit.ly, sim resources under spreadsheets, this is a tool that allows us to use Monte Carlo simulation to know what the likelihood is that we're going to deliver on a given feature. I just want to introduce the basics of how to use it, so you understand why we're, oops, I don't want to end the webinar. I just want to go out of full screen mode. There we go. So that you are able to understand the benefit that we're presenting here. So, Artie, can you see when I highlight different cells?
Yes, I do.
Thank you.
Yes.
So the way that the single feature forecaster works is it seeks to answer the question, when is it going to be done, more effectively than anything I have seen do so. Basically, what you have here is a start date. When are we going to get started working on the feature? And the instructions are all there. The step-by-step is in the instructions workbook. So you start with the start date, and then if you're guessing how many user stories you have, there are some tools to make that guess better that we can also leverage. But for now, let's just say we have a feature and it's, you know, between 37 and 45 stories. We think at the upper end it's not going to be more than 45. At the lower end, it's probably not less than 37. That's the size of the feature that we're trying to predict the delivery date on. Then the split rate, this is missing. There are other forecasting tools out there, but the split rate is not in them. A lot of times people are familiar with doing user story workshops or Agile. I made it too big. The reason that says NA is because it's further out than a year. And we don't know what else is going to change in a year. so we don't make it available. We don't calculate, what are you going to get in 7 years, because we don't know what's going to happen. So we're saying on here that when we get together for the user story workshop, or we actually dive into the work, at the low end, stories stay the same. We don't tend to remove stories. At the high end, a story, every 2 stories gets an extra story split into it. So we have a user story workshop. We say, oh, let's look at what these stories mean to us. Every other time we run the user story workshop, we discover, oh, actually, there's another story we need. So we're able to factor that into our options. And then this isn't important. It just basically states that we're simulating across 7-day weeks, which is true because there are 7 days in a week. And this gives us the option to use historical throughput data or an estimate. So you can say, I'm estimating that we do between 1, let's say 3 and 5 user stories a week. And that's the high guess. And then it calculates. And if you use data, then you just have to put in some throughput samples, a number of how many stories got done by a team in a given week. Any random samples in here will allow the Monte Carlo forecaster to do its work, which we'll dive into how it works later. So the main point here is teams now have a tool they can use to change the conversation from how aggressively can we schedule or how hard can we strive to this is what we tend to deliver and this is what you're asking of us. So given that that's the case, here's the likelihood that we're going to deliver on these dates. One of the things that come from having this conversation is we can look at existing scope and dates and pretty quickly discover that when you look at these likelihoods, that the dates for the scope given, they're very seldom in the yellow range. They're typically in the 5% or less. And so we're not saying, here's a perfect prediction. We're saying what you're asking for has a less than 5% likelihood of happening. And as we're saying, as Troy is saying here in describing what these different probabilities mean, you still get to decide as the person with the positional authority or the product group. You're more than welcome to say, I want this thing in April. There is a very low likelihood that April will happen, but let's go for it and see what happens. But I've seen this have significant impact, positive impact, because the technique works and gives you much better certainty than you had before. And likewise, if you have questions, I'll do what I can to answer them as we go. I'm not averse to. Sorry?
Yeah, maybe one before we go any further. So can you talk a little bit more about the Monte Carlo technique? Just where it comes from. It's the casino, right? It's all about the casino?
Yeah, that's where it came from. It was a guy in the 40s playing solitaire, trying to work out the probabilities. Figured out that there was a better technique to pursue, and that's where we're headed next. If there are any other questions immediately about the tool, I'll talk about the way that the stuff works.
Not so far.
Okay. Back to the thing. Did that switch effectively, I hope? So the reason we're doing this is because right now the methods that we have are worse than chance. A coin toss would actually put us in better stead. There's, of course, a somewhat vitriolic no estimates movement that says we shouldn't waste any effort whatsoever on estimating. Maybe more toward the middle there. I think we should do a better job of where we use estimates and to effectively learn what we need to know. The point of Monte Carlo forecasting is we can significantly improve the likelihood that our estimates are on the going to happen side of the scale versus the wrong more than half of the time side. So now we're going to talk about how Monte Carlo works is down the line. We're going to talk about statistical probability because that's the basis of how this works. And I know I just said words that nobody likes to hear, like statistical probability. It's really not that complicated. So a quick exercise for you guys. You're welcome to type the answer if you like. I can assure you that there's no trick here. This is a very straightforward question. Question number one is, how many different possible values are there for a standard six-sided dice? So given a six-sided dice, how many possibilities are there? I'm not seeing any answers.
Not yet. Oh, 6.
Bob says 6. Ding, Bob is right. There are 6. So
Yay.
how many values of six-sided dice are less than 4? Might take a minute.
3.
Right. So
Yay.
what's the probability of rolling less than a 4 on a six-sided dice? Oops, I switched.
0.5.
Right. So
Adam, you have a tough crowd here.
I know, right? So there's a 3 in 6 likelihood, which translates into 1 in 2, and for the sake of probability, we translate that into a decimal number, which is 0.5. This is all you need to know about statistical probability to be able to use Monte Carlo in your work. So there's another sheet to the probability questions. A lot of this stuff is done in a workshop that we're happy to come up and do in person. All of these are also Creative Commons and offered by Troy on the Focused Objective site. I've made a bit.ly link so that you can go to the probability questions worksheet yourself and enjoy the fun of answering the rest of them. But the basics are, probability is just how many out of how many. How many possible correct answers out of the total correct answers. So I've gone into math. I know it's painful, but it's pretty simple, and hopefully I haven't lost too many of you folks by diving into the six-sided die. So what we need to know in order to simulate, the way Monte Carlo works, the thing that spreadsheet does is it takes that range that we've given it and it runs 5,000 simulated deliveries or cycles. It says 5,000 times when did we deliver this thing. And what it needs to know in order to essentially roll dice 5,000 times is, what are the values on the dice? What's the range? We know on a six-sided dice that it's 1 to 6. We don't know necessarily on a given team what the low end and the high end of that range is. So if it's, let's say it's 3 to 5, I'm going to go back to the spreadsheet. If it's 3 to 5, then what the Monte Carlo simulator is going to do is roll a die that at the low end has a 3, and then has a 4, and then there's a 5. And it's going to roll it randomly 5,000 times. So this is a chart that you can look at. It's a simulated burn down chart of completion dates. And so we're saying, given the scope, which is up here, how many stories, there's our range on the left here. Given how many stories we have to do, we're going to simulate every possibility and give it all an equal likelihood. So numerous instances of the team completing 7 user stories in a given week will have passed through that 5,000 simulations, and numerous instances of the more pessimistic, the team getting 3 done, will have passed through those 5,000 estimates or 5,000 simulations. And all the Monte Carlo forecasting tool is saying is, given we have this range and we have simulated, e.g. rolled dice, where's the 85th percentile of the date? Where did we deliver before or on 85% of the time of those 5,000 simulated runs? So this is just a statistically more sound way of guessing when we're likely to deliver. It uses a very small amount of sample data, and because that's all it needs, to populate the sides of those dice, and then it rolls them 5,000 times for you, because computers are better at rolling dice 5,000 times than people are, and then it gives you a distribution of dates. Any questions?
None so far.
Sorry, Bob. Stats are hard. 3 out of 6. So that's basically it. That's how the Monte Carlo tool works on a single feature basis, and that's the core of this thing. So how do we find out what the sides of our dice are? Is there a better way than guessing? Guessing really isn't that bad on this scope, because typically speaking, if you ask an engineering team how many things do you tend to get done in a week, it's not crazy off. You know, they're not going to, you're not going to have one guy that says we get 7,500 user stories done a week and another guy who says we never get any user stories done per week. The range is going to be close, certainly close enough to populate our die. But that said, a better way to populate the die is through sampling. It gives us a way to make predictions quickly and reliably. And the reason that we're going to talk about sampling is because the number one pushback that I get from people when I talk about this is they say we would need so many samples. It would take so many samples of the user stories that we have. We would need thousands of samples to get to any kind of certainty about what that range is. Remember, what we're trying to find out is what is the high and what's the low. We have a prediction intervals exercise where we roll a 100-sided die, because that's a range we know. We know that if we roll a 100-sided die, at the high end we're going to get 100, and at the low end we're going to get a 1. So what that does for us is allow us to simulate trying to discover the range of an unknown data set. Like, if we didn't know it was 1 to 100, how far would we have to go before we had discovered 80% of the range? I did the, it's dangerous, I'm always at risk of ending the webinar whenever I get out of full screen mode. So
You're still good.
Good. So I ran through one myself just this morning with dice I had in my pocket because I'm a nerd. And this is typically what happens when we roll the dice. What this does for us, and the worksheet is on the site as well, we're trying to find out, when do we get to 80% of the range? When do we know that we've discovered enough information to feel confident that we understand what the range is that we're using to simulate? And in my case, new information, which is what we're after when we sample, came at, well, the first, of course, is going to be new because the second sample is going to be new information, but then I didn't get a new lower limit until 4, and I didn't get a new upper limit until 5, and then I hit the big time on my 12th sample. And the expected range using the equation is about on par with what I saw. So when you get to about 7 samples, you're already better than chance. You're already way better than a coin toss, and most of the biases we bring to the estimation discussion are worse than a coin toss. It's like taking a coin toss and exacerbating it with cognitive bias and positional authority and Protestant work ethics. If you have 7 samples, then you can be pretty confident that you've beaten the coin toss for your Monte Carlo simulation. So if you look at this table, it shows you the equation, n being the number of samples, n minus 1 divided by n plus 1 gives you the probability range that you found, the probability that you found the range of the sample set, or the data set. The two big things to take away from this is how quickly you get to something better than chance. I mean, by the 4th sample, you're doing better than chance. By the 12th sample, you've hit that sweet spot of 85%. And the reason it's a sweet spot is if you look at these numbers, 4 was 60, 12 was 85. So if you look 6 past 12, so if you look from 12 to 18, we only got a 4% increase in new information, a 4% increase in our understanding of that range. So not only do you get enough information by the 12th sample, the return on collecting more samples is significantly diminished. So you can see from the equation here that by 30 samples, we're at 94%. Now, we also happen to live in an era of electronic tools, tools like LeanKit and its competitors. Those tools give us actually a lot of access to data. One of the key things to remember is random samples are important. If you bias, if you only take high samples, then you're going to screw up the data. So getting a random set of samples in there, good stuff. And as you continue, don't get the samples one time and then use those for years to come. Continually collect new, fresh samples. A good heuristic, if you want to be really certain on your samples, is just the most recent random 30 samples. This will give you a pretty good understanding of what's likely. I see questions.
Yes, there are. So there are some questions about the fact that we assume we have a sufficient sample size, and also we have to take account of the team competencies for types of tasks. For example, different team members will do things faster or slower, which supports the usage of story points.
Sure, yeah, absolutely. But in the grand scheme of things, a lot of that stuff will come out in the statistical wash, as it were. Story points also, you can do the, sorry, I didn't point that out. Oh, keep trying to cancel the webinar. I didn't point that out that we can use throughput or points. It's not essential that you use that's the wrong one. There we go. It's not essential that you forecast using throughput. You can use velocity as well. And absolutely use story points, use throughput. It's still going to give you a better than chance outcome. Now, the question of competency and whether that impacts the total output of a given team meaningfully, that's a different discussion, and certainly something that you can model and understand. And there's some tools on Focused Objective that will allow you to understand your specific capabilities within a given team. Are we overbalanced to front-end development, or do we have too many back-end people? What's the constraint on skills that we need is certainly a factor. But I think you'll find, statistically speaking, when you do 5,000 simulations, whether or not one developer is able to outperform another developer, or we're talking about mythical 10x developers, isn't really a huge factor. And again, we're also not looking for data at that granularity. We're looking for data that has decision value, that allows us to make choices that we wouldn't otherwise make with regard to our capability. There's an RD request.
That's okay.
Cool. So I hope that answers your question. Sure, by all means, if story points are useful for you to understand team capability and balancing those things, go for it. Whether you're using story points or you're using throughput, you're going to get a reasonably better forecast out of this than you would get from just extrapolating the velocity or the burn up of a given team. There are other aspects that I'm not going to go into too much right now. Like, there's an entire panel on risk that allows you to put in an estimated likelihood of increased scope, or of somebody, half the team is going to go out of town, or there's, that allows you to understand. It shifts the ranges and says, if you have a risk that your scope is going to grow by 100%, then we're going to simulate those things happening too. It's going to move the range. So if story points are good for you, awesome. There may be slightly more variance in story points, just because I see folks doing interesting things with that abstraction. We did 2 forecasts, one with story points, one with throughput, and the story point one was maybe a month longer, which in the grand scheme of the portfolio isn't the end of the world. I wondered why that was, and we found that because the deep in the product backlog hadn't been story point estimated yet, they just put like a 20 on everything. So that kind of thing doesn't happen with throughput, and is throughput is less susceptible to that sampling bias of them just saying, well, we don't know what those are, so let's just stick a 20 on them so the tool is up to date. So yeah, story points.
That goes.
Sorry?
Yeah, there is a note here saying business people always overestimate what developers can deliver.
Absolutely. Here, here. And that is what this is about. And the story I tell about the single feature forecaster, I was working with a large financial institution and a business person. I hate that dichotomy. I think we're all business people, but I realized that it exists. And a business person who was known for vehement and heated disagreement with developer estimates asked when something was going to be done. A dev manager with a lot of experience there, who I think is very credible, came back and said, I think we'll get this thing done in September. And that business partner went to 2 offshore teams who said they could get it done in June. And of course, these are all guesses. The business person liked the June guess better. And she came back to the development manager and said, why are you sandbagging me? I expect this in June. So time goes on, and they're not able to start on time because of the crippling web of dependencies causing delays in the front end, being the start date. And the extrapolation started to look like December. So there was going to be a come to Jesus moment wherein the typical angry exchange between the business and that dev manager would occur. But this dev manager had the tool now. He ran through the forecast, and he saw that it looked like, given the sampling of their past performance, that they were going to hit September date. And I always say a lesser man is, or a lesser person would have come back and shown that to the business partner and just yelled, ha, and said, I told you so. But this guy said, what does it have to be June? She clearly wants June. What kind of thing can I do to make June happen? So he looks at the throughput history of this offshore team that's got specific capabilities in this area that's, yada, yada, yada. He figures out that if he takes a component of what they're working on that is still independent and won't split the sort of vertical slices of what they're doing and gives it to that offshore team, they come in June, at the 85th percentile in June. So instead of going to her and arguing with her, he shows up with the forecasting tool and he says, here's what I discovered from analyzing her data. And she was delighted. There was no anger. There was no fight. And that's exactly what they did. And in fact, as a result of the typical measures of adding people to that team not being applied by just moving work around, the 2 groups actually were tripling and quadrupling their progress towards completing this work. And they didn't just run that one forecast and then go with it. Week by week, as they developed new throughput data, they updated the forecast. And the business partner was so delighted with how steadily they were delivering to the forecast that they were looking like May. And she asked, what if we add this scope? What date will happen if we put this additional work in? And they ran the numbers, and they said it looks like September. And she said, if I can get this in September, I will be delighted. And they did that, and they continued to communicate with each other, and they continued to update and share, when context comes in, oh no, the team got like nothing done this week because things went badly or this thing happened that we didn't expect. Great, that's another sample. That's more information that informs the forecast. So what happened was that team delivered with high quality all of that scope pretty much exactly on the date that the forecast said it would deliver, and trust was born. They no longer argue with each other about what's possible. They look at the data and they make decisions about what they can put in as a result of it. This will be a continuing theme. So I hope that helps. I see another question. Yeah.
Yeah, I didn't know if you want to go back on your presentation or for a bit more and then questions, but
yep,
up to you.
Got it. And that's a good idea. So back to the presentation. So this is an experiment that you can do on your own time from, like I said, with this prediction interval exercise. This is my outcome. I got to a range greater than 80 by the 12th sample. Good. So where this sampling stuff came from, where the equation comes from. In World War II, there was considerable intelligence benefit to knowing how many tanks the enemy had in the field, so we could inform the decisions that the Allied forces can inform the decisions that they made with regard to where to put our tanks in the field and where to put our troops, and what D-Day kind of decisions we could make from a staffing and load perspective. So the intelligence community was asked to come up with an estimate, and they estimated that there were like 1,000 tanks in the field based on information about how many tanks we produce, all kinds of interesting but not super useful finger in the air information. And some data nerds got together and said, well, you know, what if we applied statistics to it? Germans numbered their machinery, their tanks, sequentially. They didn't know enough about, you know, encrypting serial numbers. So, you know, you could actually know from looking at the serial number on a tank what number what number in the production line it was built. So the problem was they only had 2 tanks. So how do they predict with only 2 tanks? They discovered that the bogie wheels, which are those wheels which support the tread, there are 8 of them, and there are 6 bogie wheels per, and each one of those is sequentially numbered. So they did the equation, the London taxi problem, on the serial numbers of the bogie wheels on the tanks. And what they came up with was, in 1942, they estimated that there were 327 Panther V tanks in the field. Intelligence thought there were 1,550, and in the post-war, they found there were actually 342 Panther tanks manufactured by the German forces. And this simple equation, the London taxi problem, which you can look up and dive into, it's the same equation that we're using here, but really only focused on the upper number, worked. So this kind of data-driven approach works. And if you run into folks who say, but the problem is we need all the data, this is my favorite joke about what to tell people who don't believe that sampling is effective. If you don't believe in sampling, next time you go to the doctor, ask them to take all your blood. Usually that gets the message across.
That might not be a good idea.
No, you need it. Like, it's got to be in there. And there's a book coming out from Troy on forecasting, and he makes the good point that there's a lot of assumptions involved. You know, that's part of why simulation is valuable. You know, if you're cooking a soup and you're using a soup mix and you've got a big pot of water and you dump the soup mix out into the middle, but you don't stir it up, random samples of areas of that pot are not going to be reflective of the ingredients in the pot. So that's why we use multiple techniques. And that's a general recommendation for this stuff. Don't just do this. Don't throw away useful things that you're doing and do this instead. I'm not saying that. I'm not saying stop doing planning poker. I'm saying continue doing both things and compare the results that you're getting and make decisions about, you know, what's most effective for you. We've got someone here in town who's worked at the University of Washington, and she introduced this tool, and they discovered that the story point estimates they were coming up with were not useful for forecasting. They weren't giving them the information they needed about delivery that the forecasting tool was giving them, but they were having great conversations about the complexity of the product, and they were learning a lot about where they had disagreements, and they were getting better shared understanding from the planning poker sessions, which is the reason for planning poker. Planning poker is not about getting to an accurate estimate. Planning poker is about having a conversation about complexity and risk. So they kept doing it. They still have planning poker. They just don't use the points for forecasting. They use the throughput for forecasting, or if they chose to, they could use the points with a Monte Carlo simulator to forecast. So we've covered how Monte Carlo works. And now we're going to get into the portfolio stuff. So portfolio management is a range of investments. It's something that is not as well understood as I would like it to be. An organization has a limited amount of resource to invest. And by resource, I mean money, hardware, all those things that are not people. That they have this much budget to spend, and their job is to maximize the return while minimizing the risk. And all of that is in service of the customer, because most organizations make their money by being remunerated by a delighted customer. So given that, it's surprising that the way that these systems are managed are to jam as much into the delivery pipeline as possible, give people the biggest possible load. In fact, I worked at an airline for a brief time where the new director of program management came around and asked everybody if they could open the requirements for as many projects at the same time. Like, hey, could you guys go in and look at all of the Gantt charts and the specifications, and then update our project status tool with like a 1%? Because if you do like 1% on like 10 projects, then that'll like show an aggregate 10% increase in progress. So she's actually asking everybody to start everything they could as soon as possible, even if all they did was look at it, so that the metric of progress would tick up and she could report that upward and say, look, progress. Of course, starting everything at the same time is not the best plan. Portfolio management is about understanding scarcity and applying your capacity, your scarce capacity, to the highest value demand that you can. This is a perfectly stable system. We have exactly as much work arriving into our system as we have departing. And it's not just about work, it's about value. We're doing the highest value thing, and we can get every single thing that's being asked of us done. I'm sure everybody has experienced this. This is probably what you all see day to day when you go to work. You have exactly the amount of work that you have the capacity to complete to do, and nobody's overloaded. Or you work where the rest of us work, and there's way too much stuff. The challenge is teaching people that when they choose to do something, they delay the doing of something else. And that seems like a very simple, basic concept, but again, that person wanted everything to tick up 1%. I run in all the time. I've been in stand-ups at software companies where the director shows up and says, I want each one of these developers to be working on no fewer than 8 development tasks each on a given day. If you're working on 7 or 6 or 5 development tasks, then you're not working hard enough. And of course, if you're not working hard enough, you're a bad person, and you're the reason that we're not going to deliver, right? And if you start to actually look at the relationship between the amount of work that's in progress to how quickly any given piece of work gets done, I'm not going to harp on about Little's Law, but that's where you're going to find the proof of this. Then you understand that that's not a great way to go. So again, I'm not going to cancel the webinar. The multi-feature forecaster, I'm going to show you the multi-feature forecaster and then tell you a story about it. The easiest way to look at this is it's a bigger picture cut line forecasting tool. It's embedded, the single feature forecasting tool, the Monte Carlo, is embedded in this, and that's where these checkboxes come from, or the X's. So I'll tell you, same financial institution, an Agile coach there who'd been working with me was helping a Scrum Master on a team of 25 people, and they had 3 significant initiatives that were underway. And this Scrum Master and coach were trying to use the multi-feature forecaster to find yes, because they had worked with that dev manager and said, wow, this is great. And what was being asked of them was that all 3 of these very large initiatives be delivered in June. And when they put the data into the multi-feature forecaster, these checkboxes mean that there's an 85% confidence interval, 85% likelihood that we hit the date. So up here we've said our target date is July 1st, our start date is January 1st, and we want to know what's 85% likely. Of course, we still have a split rate, and we're still defining a week by 7 days, and we're telling it whether we're doing an estimate or using the data samples. What happened was they found that the first one was a check and the other two were X's. And this was assuming a lot of things. This was assuming that the team was working collaboratively together on completing the first feature and then working on the second one. This was not the case. The team was working on everything at the same time. They were highly specialized. You know, if they didn't have a developer who could work on feature 1, then that developer would go work on feature 3 because that's the thing that they were good at. And so we were able to say, despite the many things he tried, you know, what if we do a part of feature 1 and then a part of feature 2, and he moved the stories around and tried to add teams. Whatever they did, they weren't able to get to even working serially that June date. And what was great about this was it was immediately apparent to the managing director of engineering in the room, not only that they needed to work more serially, they needed to stop, you know, sharing people across 3 different projects and expecting them all to deliver as quickly as possible. But she said, without anybody telling her, she said, we really need to push back harder on prioritization. Like, we need to decide which of these 3 things is most important. And there was a managing director of product in the room who didn't argue with her. He said, you're absolutely right. We're not going to get any of this stuff in 2 years if we don't make a different choice about how we're going to deliver. So these things aren't, again, about a perfect prediction. It's to help us see with data how wrong we are. And the value of that, especially if we have safety, if we can actually question these dates and have those discussions with leadership, is that we can actually model what is likely to happen and make decisions earlier about what scope to cut or what risk to mitigate. You know, those choices come from this conversation that the data causes. And we don't have to deliver all 3 of those portfolio investments to find out that our plan was wrong. We can model it and know we're not looking at, you know, 70%. We're looking at below 5%. So given that it's below 5%, you know, what do we have to do to get it up to chance? What kind of things what can we change to get us closer to a good outcome? So pursuing an option delays other options. That means you've got to decide which of your babies not to work on. You know, the way that a lot of enterprise portfolios are run right now is we just assume that we need to get everything started as soon as possible, because not doing so is irresponsible. If we want to get all of those things finished, they must start. Saying you need to decide which of these you want, and then we will work on that until we start to wind down that threshold, and then ask ourselves what we can do to grow our capacity, is, I think, a healthier way to manage your portfolio. The thing that happens from having to pick one of those is invariably somebody says, but wait a minute, I thought they were all number 1 priority. Well, if they're all number 1 priority, then none of them are number 1 priority. So you need some mechanism to tell you how to do that. You need to find a way. So Principles of Product Development Flow, Don Reinertson wrote the book on prioritization and second-generation lean product development. Cost of delay is essentially quantifying what the opportunity cost of making value that we release wait. So the simplest way I can put it is, if you have 2 things to do and both of them take 6 months each, if you work on one and finish it in 6 months, and they both have the same revenue return, if you finish one in 6 months, then over the course of the 6 months that you're working on number 2, you are collecting the revenue of having released the first thing. If you work on both of them simultaneously for the whole year, you did not get the revenue for one of them for 6 months. So you lost that money that you could have made over those 6 months. I hope that was a simple way to explain it. So you have to ask yourself, what matters to you? How do we quantify business value? And there are tools that help with that that I'm not going to go into, but I will at least show you what some of them look like. This is the cost delay prioritization calculator. And I'm not telling you that it's totally that it's objective. It's not objective. The amount of money you think you're going to get for a thing, or the outcome you're going to get, this isn't just about saying, we want to do the thing that's going to get us $100,000 more than we want to do the thing that gets us $50,000. Maybe we have a mission. Maybe we're here for a social good, and we need to make a decision that costs us opportunity cost, that's going to prioritize something that fulfills an oblique mission-driven need over something that gets us more money. But the main point that I want to make is, instead of us just assuming everything is the most important thing and therefore cramming way too much into the system, we are actually trying to have these conversations. And what I have seen is these conversations tend to emerge more readily when we have some data and some statistically sound thinking to provide. I'm not saying that you show up and beat people over the head with a forecasting tool. When I go to somebody and show them how to do this and they're completely uninterested in it, I move on and we go do something else. But the point is that when your coaching or your process improvement efforts hit that point where somebody says, well, then I need to know what's most important, then having tools to say, here's how we do that, will make for a better conversation and a better outcome. And the interesting thing about these portfolio tools, or these approaches to thinking about value in the system, is they allow you to apply an opportunity cost and value to cycle time. So if you know that having heavily dependent teams delays the work going through the system, but you have heavily dependent teams because, well, we've always done things that way, you can now actually look at the total lead time of the work you're doing, find the delays, add them up, and then see how much opportunity cost you're losing. And the reason why I want to focus on value and opportunity cost instead of how much you're paying people and what the overhead is the number is much, much bigger. We don't barely break even on a software developer in the software world. We make a lot more money than we spend on the salary of a developer, especially in the enterprise. Sometimes 9 figures is what we're talking about. So when you look at that number and you say, we've always done it this way, and always doing it that way is costing us 6 months of team cycle time, and that 6 months of team cycle time across our $2 billion a year portfolio of revenue is a 9-figure number. It's a lot easier discussion to have with executive leadership about maybe we shouldn't have dependencies, or maybe we should create cross-functional teams, maybe we should slice our work vertically. We're no longer just waving our hands in the air and saying, but Agile says you should be a good person. We're saying, no, this is actually good for your business. This is where you get money out of the deal. Of course, being a good person is good for your business too. Unfortunately, it's sometimes a tougher sell. So the key point that I want to make is you always want to be updating your forecast. You always want to be gathering new data, and check your forecast against other methods. Double the average. Look at other techniques and compare your forecast with those and look for errors. It is not a perfect solution. You may be sampling incorrectly. You may be getting wrong information. There may be bias in your data. And so try other things and compare it against your forecast. And by all means, if you find something that gets you better than 85 or 90 or 95%, please let us know, because we're not married to a given technique, and want to be clear that the interest here is not to be dogmatic and say you must do this or you must not do this. It's to say this is a tool that significantly improves your fidelity of information, and that risk still exists. You have to ask yourself, even though there's an 85% chance I'm going to hit this, if that other 15% happening represents a significant, severe, unacceptable existential risk, then I need to do more than that. 85 is not good enough. I need to go for the 95 date. It's not, always do one or never do the other. It's use your brain, ask questions, try to understand risk. And I get surprisingly often, what do you mean 85%? You mean it's not 100%? And the irony of that is nobody ever has a 100% thing. I always say, well, yeah, it's only 85%. Please show me your 86% outcome. I want to learn why this doesn't work. And by all means, ask me, shoot me a line afterward, tell me what's wrong. I want to learn why this isn't valid, why this isn't helpful, or it doesn't work for you. I want to know all of those things because they help me learn this better or discover if I'm, a blithering idiot who's just wrong. Like, I'm willing to accept that that's a possibility. So the main point here that I've tried to drive home is these tools give you information with decision value. You're going to be able to make a better decision because you have this information. And that's the most important thing. I had a dev manager who was asking the team for daily effort hour estimate updates. Like, I want to know how many effort hours these stories are going to take you each. And at the end of the day, I would like you to submit the number of hours you put into that. And I asked the team, what different choices is he going to make because of that information? And they said, we don't know. And I sat down with him and I said, let's talk about that, because he brought it up. And I said, so what are you going to do with that information? He said, well, I'm just trying to be diligent. I want the information so that my data is complete. I want to make sure that I'm doing a good job as a manager. I said, great. So based on that data, what choices are you going to make? And he said, I don't know. What choices should I make? I said, well, let's explore it. And we dove into it, and we discovered there really wasn't any decision value to collecting that information. He wasn't going to be able to do something different based on whether that number was high or low or indifferent. He was just trying to do a good job, and there was nothing wrong with that. People are not bad people. Bad metrics don't exist because people are evil. Bad metrics exist quite the opposite, because they have the best intent. So every spreadsheet and exercise worksheet is up here on SIM resources. Focusedobjective.com is where you go to get, I think, some of the best metrics, data. The blog is excellent, and there's some really good stuff specifically to answer Bob's concerns about capabilities and the different load capabilities of teams. That stuff's emerging right now, and it's I think very interesting, and I would encourage you guys to go there and challenge Troy, challenge me. Anybody have any questions?
There are no questions waiting. I guess we took some of them going on. There is one around the risk being a useful tool for scope creep for PM.
Totally.
So scope creep.
Yep, and that's covered somewhat in that risk panel. That's exactly right. We're saying, we believe because of the type of work that we're doing or because of this domain, there's a 50% chance that we're going to see another, 35 stories, or we're going to see another 150 velocity points, or whatever you're using as your measure.
You can see Bob saying empirical tool to compute empirically the risk.
Exactly, and it's more. I think it's more sound. It is better than what's out there, and it's always down to the people. Just to share an anti-pattern, another director at a place was working, and that person had used the forecasting tool, and her date looked like 85%, and she was really happy, and she communicated that, look, guys, we're going to hit the date. We're a good team. But she didn't factor in a dependency. And she knew that dependency was there because usually when they miss their date, it's because of that dependency. But that risk was never put in there. And then one day, the dependency hit. And the previous day was an 85% likelihood, and now, boom, it's 35%. And the optics were terrible. She looked really bad, and she was very angry, and she blamed the tool. And that's the risk of these things. I've also heard certain management thinkers saying, well, I don't like that date. Well, of course you don't like that date. It's real. It's the truth. It's what's going to probably happen. And then saying, well, the reason the date is so far out is because the team is lazy or they're not working hard enough. They just need to work harder. And I didn't add the link to it in here, but there's a great paper also on focused objectives called the economic impacts of cycle time. And if you read that, there's some really useful information about whether or not, given the type of work you're doing, overtime will help, whether crunch mode is effective. The spoiler alert that it's generally not. Like, the data shows over tens of thousands of teams that it's generally not. So those are some risks to think about when you're looking at this tool. That used improperly, it can cause consternation and pain.
Okay. So there are some questions about the link. Probably, Adam, you can send those to me. I will follow up with everyone, or you can go one slide back where you have the link. And,
Yep, I can totally do that right
and
now.
The link to the paper that you just mentioned. Oh,
yep, and it's up there as well. So the Bitly Sim resources also has a link. It'll take you to a GitHub repository with a number of directories in it. The spreadsheets, the tools are under spreadsheets. The paper I mentioned is under publications. It's all very easy to find from there. And of course, reach out to me if you have any questions. I'm adam.yuret@contextdrivenagility.com.
Wonderful.
And I'm happy to answer questions and help any way I can, because I want to get more data to continue my evolution and learning.
Thank you so much, Adam. I will take a little bit this presentation now from you.
Ah!
Yes.
Powerless.
I have the power to do that.
Power.
I just wanted to close. There are some exciting news coming up. We have the open space for Toronto Agile registrations now are open. It is going to be on April 8th. You can go register now, but please follow up with us, send us feedback on this webinar or others that we have done before. Please suggest us future topics that are interested to you, and stay in touch with us in whatever way works with you. Adam, thank you so much for all this very smart presentation. I'm sure I'm going to have to listen it again to understand everything you said. Takes a couple of times. Plus, I need to work with that spreadsheet. So thank you very much again.
Yeah, and please try it and let me know how it goes for you. I'm happy to help anytime I can.
And thank you everyone that attended for your questions and for your participation. We'll see you in our next webinar. Bye.